This next unit, we're going to talk strictly about triangles, all things triangles. So we want to start out by being able to classify our triangles so that when we talk about the different types, we'll all be on the same page. So the first way that we can classify triangles is by classifying them by their sides. So we have a scalene triangle. A scalene triangle has no congruent sides, no sides that are the same length. You might have it marked like this, or you might have it marked like this, where your side lengths are all different. But a scalene triangle has no congruent sides. An isosceles triangle has two congruent sides. Technically, it's at least two congruent sides. You'll notice, though, a couple of things that you need to remember about an isosceles triangle. That when you have an isosceles triangle, these angles that are on the base, the bottom of it is called the base. They are called the base angles. And then this vertex up here, this angle is called the vertex angle. And we'll look at some problems later where we need to use those definitions. And then the two congruent sides, those are called the legs. So an isosceles triangle, by definition, it is classified, it's a classification by sides because it has two congruent sides. And then lastly, we have an equilateral triangle. An equilateral triangle means equal, lateral means sides. So an equilateral triangle has three congruent sides. So technically, an equilateral triangle is also an isosceles triangle because it does have two congruent sides, but it's kind of like a square is a rectangle, but its best name is a square. So we would never classify a triangle that has all three sides congruent as being isosceles because it needs to be better than that. The other way that we can classify triangles is by their angles. An acute triangle has all three angles are acute, or all three angles are less than 90 degrees. And so you might have 30 and 70 and 80. All three of those angles are less than 90 degrees. So you can see it either by its angle measures and by appearance also, it's less than 90. Obtuse, so an obtuse triangle has at least, or it has one angle that is greater than 90 degrees. It can't have any more than that. So you might have that this angle is 100 and this angle is 60 and this angle is 20. As long as one angle is greater than 90 degrees, then it is considered an obtuse triangle. A right triangle, you can see a right triangle here. Your two legs form the right angle that is denoted by the little square in the corner. And then the side that is across from the right angle is the hypotenuse. Okay, a right triangle then, when you're classifying it by its angles, is a triangle that has one 90-degree angle. The other two angles add up to 90 degrees, so there can only be one 90-degree angle. And then lastly, we have equiangular. So if equilateral was equal sides, then equiangular is equal angles. So it has three congruent angles, which means that all of the angles have to be 60 degrees. So we can either mark them as being congruent, like these with the symbols, or we can mark that they're all measured 60 degrees. That comes from 180 degrees, that the angles of a triangle add up to be divided by 3 is 60. Now you'll see at some point, you'll see the word regular. A regular triangle means it has equal sides and equal angles. So that word may come up every once in a while, but if you ever see the word regular, then that means it has equal sides and equal angles, which an equiangular triangle and an equilateral triangle has to be regular. So if it is equiangular, it has to be also equilateral. So if it has equal sides, then it will also have equal angles. Just kind of like this one up here, when you notice with the isosceles triangle, when you had the two legs that were congruent, two congruent sides, notice that you have two angles that are congruent. So that happens the same also. So the question is it possible for a triangle to be right and equilateral? Can it have a right angle and have three sides that are congruent? No, because to be equilateral, it has to be equiangular. Okay, so equilateral means equiangular. That is also the same thing that would answer obtuse and equilateral. Can you have an obtuse angle, an angle that's greater than 90, and have all three sides congruent? Well, if you tried to draw it, it's very obvious. If you kind of draw it really way out, then you can really see that there's no way that you could have both obtuse and equilateral. So, didn't finish my words. So, when it's equilateral, no, the only option that you have is for it to be equilateral and equiangular. So let's classify these triangles by their sides and their angles. We'll learn more about being able to classify them when you don't have information, such as their sides and angles, a little bit later on. So we first notice, if we classify it by its sides, I look at my side measurements. I notice they're all the same. That means that this is equilateral. And then we know, based on the discussion we just had, that if it's equilateral, it's also equiangular, but we can see that it is also marked as such. Each of those angles is 60 degrees, so it is also equiangular. Okay, so we look at the next one, number 2. Look at the three sides, 6.1, 8.7, and 7.4. Since they are all three different measurements, we know that that means this is a scalene triangle as classified by its sides. And then we have 79, 57, and 44. All of those angles are acute, which means that it is an acute triangle based off of its angles. Number 3, based off of its sides, we have 11.2, 7, and 13.2. They're all three different, so based off of its side, it is considered a scalene triangle. And then we have a 90-degree angle, a 58-degree angle, and a 32-degree angle. And so we base it off of the 90-degree angle, so it is a right triangle. So it would be considered a scalene right triangle. Then number 4, look at it by its sides, 2.5, 2.5, and 4.5. Since two of the sides are the same, by its sides, it is considered isosceles. When I spell that, I spell it I-S-O-S, and then so isos, and then celes. So if you need help learning how to spell that, that's how I think about it when I spell it. And then we have the two angles that are the same. Obviously, we have two sides the same, two angles the same. And one of those angles is obtuse. It doesn't have to be that way. Isosceles doesn't always have to be obtuse isosceles. It can be acute isosceles also. But in this case, we have an obtuse isosceles triangle. So let's look at how to do some of these when we're looking at them on a grid. So we don't have any side measurements, but we can use what we know about slopes, which kind of leads us to Pythagorean theorem, but there's not really any reason to do all of that work. So let's just look from B to F. I could do Pythagorean theorem and calculate the length of that side, but really what I just want to know is, are they equal or not? Because scalene is no equal sides, isosceles is two equal sides, and equilateral is three equal sides. And so we can just look at our slopes and determine whether those are the same, and if those are the same, then the lengths of the sides would be the same. So we would go up 2 over 1, 2, 3, 4, 5, 6. So up 2 over 6. We could do that same thing here. Obviously, F from F to H is very different. It would be over 4 up 2, 4, 6, 8. So this would be up 4. We have sides of a triangle that are 4 and 8. And then if we look over here at BH, then we have 2 and then 2, 4, 6. So in that case, the green triangle and the blue triangle. So if we look here at this green triangle right here and this blue triangle, those two sides would be congruent. And then obviously our FH would not be congruent because it has a very different slope, which means then that this is isosceles. So it is an isosceles triangle, and then the question is to determine whether it is a right angle. Again, we can use our slopes with that. So let's look at the numbers we have. It's a +2 and a +6. So this FB has a slope of rise over run, which is 1/3. And then BH, that line right there, has a slope of 6/2 negative, and which would be a slope of 3/1. Since those two slopes are opposite reciprocal slopes, right? Negative 3 and 1/3. Since those are opposite reciprocals, then what we know is that this is a right triangle. So yes, it is a right triangle because of the opposite reciprocal slopes. Okay, so let's look at number 6. So we'll check our slopes real quick. Notice these numbers don't come out pretty, and that's okay. Really, all we need to know is it scalene, isosceles, or equilateral? So we can go down here. Also notice we're counting by 2s. So that's important, count by 2s. So we would have from 4 to 8 would be 12, down 12, and then over to 4, 5. So BC would be 12 and 5. From A to B would be up to and then over 2, 4, 6, 8, 10, 12, 13. So we have 2 and 13, and that would be negative also. And then we have 1 or 2, 4, 6, 8 over 8 up 2, 4, 6, 8, 10. So we have 8 and 10. And so obviously none of those are the same length. None of those would result in the same Pythagorean theorem. And so this is a scalene triangle. I can also see very quickly that 5 and 12, or 12 and 5, and 13 and 2, and 10 and 8 are not going to result in opposite reciprocal slopes. And so the answer is no, it is not a right triangle. Lastly, we have number 7, ABC is an isosceles right triangle. So find C if AB is equal to BC, and A is at -2, 1. There's A. And B is at 1, 5. 1, 2. So it says that AB and BC are at a right angle. So if we connect A to B, and it says it's an isosceles right triangle, and AB is congruent to BC. So we need C to be over here somewhere because we want AB and BC to be congruent. It could also go over this direction. So I'll show you what I mean by that. So if we want to be at a right angle, then we would be at a right angle to AB. So the slope of AB is up 1, 2, 3, 4 over 1, 2, 3. So it goes, we have a slope. So our slope of AB is up 4 over 3. So the perpendicular slope, so the slope of BC would be -3 over 4. So from B, if I went down 3, 1, 2, 3, over 1, 2, 3, 4, then that would create this right triangle because that would be a right angle. And then that would be isosceles because you went up 4 over 3 and you've still got your sides. That's 4 and that's 3. So you have the same sides of that right triangle. So obviously your hypotenuse is going to be the same. But we don't want to leave this other one out. We could also go up 3 and back 1, 2, 3, 4. So we could also go this way. So we could have our BC go this way. So our other point could be here at 5, 2, and our point could be back here at -3, 8. So we could be at -3, 8, or we could be at 5, 2. Okay, the important part is recognizing to be a right triangle, then you need your slopes to be perpendicular. We need that right angle right there. And then you can go in different directions. And you would just count that slope one time over from that point because we went up 4 over 3. So we're going to do that same thing one time to go in the other direction. So we have learned how to classify our triangles by their sides, and we have learned to classify our triangles by their angles, and we will continue to develop from this.